So statistics and probability, you have data handling, line chart, bar chart, histogram, and circle graphs. Circle graph is pie graph. All these things you know, yes or no?
Yes.
Probability, investigate chance processes and developing basic probability model. I'm going to tell you what is probability model. In three different ways we can represent. I will teach you all these three models now. Then
Okay.
sampling, drawing inferences about populations based on samples. Here sample means I take only a few out of the population and tell about the population. I want to tell about the population. Some statement I want to make about the population. That is called parameters. Parameters are permanent, they don't change. But I want to get these values, two values, from sample. Why sample? Because population is very, very big. Very many number of items are there in population. Therefore, I select only very little amount of items. From that, I find out that values. That is called statistics. The statistics will vary. The values are average and standard deviation. Average, right? We will bother only about average, mean, both are same, right? And then you also have mode. Mode means maximum number of item. And then median. Median means dividing the data into exactly two halves. Left hand side 50% of the data, above that value 50% of the data. That is called median. One is mean. Are you able to see my screen?
No.
Now, data handling. First, you collect the data, develop the probability model, and predict the event likelihoods. Are you able to understand the meaning of all this?
Yes.
Okay, very good. And then compare theoretical probability and experimental probability. I explained you these two. This also you have understood?
Yes.
Very good. And then the unit for probability is either fraction or percent. Fraction means 1 by 2, 2 by 3. Numerator will be less than the denominator. The value of the fraction should always be less than or equal to 1. Or percentages. Multiply by 100, you get percent. Or the decimal between 0 to 1. Both are same. Fraction or decimal. You always give in decimal, no? You said
Yes.
0.5. Yes or no?
Yes.
I also told you, please tell in fraction. Say 1 by 2. So 1 by
Okay.
2 is called fraction. What you say is decimal. You know how to give in. And then in percentage, that is 50%. First you said 50, but you did not say percent. You should say 50%. Then you
Gotcha.
said 0.5. That is very good. Or you can say 1 by 2. All the three are correct. Key
Yes.
concept we'll see here. Chance event. Something that may or may not happen is called chance event. So you understood what you mean by chance event? No? It may happen or it may not happen. I can teach you well or I may not teach you well. Whatever I teach you, you may understand or you may not understand. That is called event. Yes or no?
Yes.
Hmm. And outcome. A possible result of an event. That means either you understand or don't understand. That is two events, right? Okay.
Yes.
I am clear or I am not clear, right? I am confusing or I am not confusing. Yes or no? Therefore, the both are together is called sample space, right? So a possible result of an event. Suppose you are rolling a die. You know, you have seen a die, no? There will be 6 faces, a cube, right? 1, 2, 3, 4, 5, 6 will be there, no? Number.
Yes.
Yes or no?
Yes.
It will be like this. Yes or no?
Yes.
1 will be written, 2 will be written, 3 will be written back, 4 will be written, 5 will be written on the side. 6 will be written.
Yes.
So it can fall either 1 or 2 or 3 or 4. So what is the sample space here? Sample space is 6. 1, 2, 3, 4, 5, 6. 0 is not there. Yes or no?
Yes.
So what is the probability of my getting either 5 or 6? 2 by 6. What is the probability of my getting either 4, 5 or 6? 3 by 6. Yes or no?
Yes.
Clear? Understood? So sample space, the set of all possible outcomes for an experiment. So I toss a roll a die. All the possible outcomes are 1, 2, 3, 4, 5 or 6. Getting 1 or getting 2 or up to getting 6. Probability is a numerical measure between 0 and 1 of how likely an event will occur. It is the ratio of desired outcomes to possible outcomes. You should know the meaning of desired outcomes. You know what is desired outcomes? What you want?
And
You want head or you want tail or you want both head or tail or you want 1 or you want 2 or you want 1 or 2 or you want 1, 2 or 3 like that, right? Okay. Divided
yes.
by total possible outcomes. All the possible outcomes is the number of events in the total number of events in the sample space. Understood all this?
Yes.
Now, theoretical probability. Theoretical probability is expected probability based on the nature of event. Based on the nature of event means what? When you toss a coin, the nature means it has got only two faces. Therefore, it can fall either head or tail. That is called the nature of the event. Probability of getting a head on tossing a coin is 1 by 2. Probability of rolling a 3 from a die is 1 by 6. Have you understood this?
Yes.
Now, experimental probability is probability based on observed frequency means number of times you get the event. Number of times you get the event is called frequency, right? So
Okay.
probability based on observed frequency from an actual experiment or simulation, right? Simulation, I will teach you later. Like for example, you can do in computers. You can do in computers. Like for example, we will try to toss a coin by simulation. Can we? So
Okay.
we tossed a coin. You assume that you have tossed a coin and tell me what do you see? Close your eyes and see what have you seen, head or tail?
I see
Head or
the
tail? Anyone?
face, the first part of the money.
Don't tell me all these things. See, when you toss a coin, the coin will fall on the ground. Yes or no?
Yes.
When the coin falls on the ground, you will see one face, either tail or head. Yes or no?
Yes.
I say head. I saw head. Right? Again, you are asking me. Again, tell me. Now, what do you see? Toss a coin again. Tell me what have you seen? Ask the question.
And I see the tail.
Okay. Now, so 2 times tail. Again. See, what have you seen?
And I see the head.
Head. That's all. 2 times tail and 1 times head. So, likewise, I can ask you 100 times. And then I can note down. This is called simulation. Yes or no?
Yes.
Right? I am just simulating by asking you what is answer. Guess. You guess an answer, and then that I am counting and putting it. I need not ask Catalina. I can ask a computer. Computer will give you a guess. Understood? Computer
Yes.
will give you million guess in 1 minute. Right? You will take 1 hour to give 10 guess. Yes or no? You will take
Yes.
1 hour to give me 10 items, 10 heads or tails. But computer will give very fast. Therefore, I can do simulation using computer very fast. Or I can actually toss a coin and then see myself. Yes or no? Understood
Yes.
what is simulation? Yes
Yes.
or no? Right? Okay. Now, I will take another problem. Your mother is going to be at home or not at home. Your mother is going to be at home or at office. Mother is office goer, right?
Yes.
Now there are only 2 events. Either mother is at home or mother is at office. So I
Okay.
consider that normally like tossing a coin, it will be 50-50. Yes or no?
Yes.
Total sample space is 50%, 50% there. One by one event there in house, another event is not in the house. So together 2 events. So 1 by 2, 1 by 2. Suppose I can ask you, no, your mother is at home today. Tomorrow I can say your mother is at home. Day after tomorrow, 365 days I can ask you, Catalina, are your mother at home this
Okay.
time? Or in one day itself, 24 hours, each 1 hour, I can ask you, hey, is your mother at home? Is your mother at home? This is called experimentally, I am calculating what is the probability that your mother is at home. Yes or no?
Yes.
Theoretically, I say it is 0.5 because either you total events is will be at home one event, not at home is another event. So total event is 1. Therefore, 1 by 2 for each event probability. This is how you do theoretical and experimental probability. And you know what is law of large number. A die is rolled 60 times. Out of that, 10 times we get 3. So what is the probability of getting a 3 by experiment?
And it's
1 second. You see my line number at the top, right? Now you will get 1, 2, 3, 4, 5 or 6. Only these are all the possibilities. Yes or no?
yes.
Out of this, getting 3 is, so only one event. Out of total is 6 possibilities. Therefore, probability of getting 3 is 1 by 6. This is called probability theory. Yes or no?
Yes.
Now, I have rolled the die 60 times. How many times I got 3? 10 times. Yes or no?
Yes.
So 10 by 60 is the probability of getting a
Uh,
3 by experiment. Understood?
yes.
So easy, no?
Yes.
Right? Now tell me, a die is rolled 100 times. A die
100.
is rolled 100 times, and out of that, 25 times I get 5. So what is the probability of my getting 5?
Um, five. Five of no one.
25 by 100, 1 by 4. Okay.
Four.
Now, out of 100 times, I am getting 30 times, either 5 or 6. What is the probability of getting 5 or 6 experimentally?
It's 22 and 6.
What is the probability of getting 5 or 6 experimentally? How many times I got 5 or 6? 30. Yes or no?
Yes.
Therefore, 30 by 100. The probability of getting either 5 or 6 is 30 by 100. So 5 is 1 event, 6 is 2 events. Total number of events is 6. Therefore, 2 by 6 is 1 by 3. Probability experiment is 1 by 3. Probability theoretical is 1 by 3. Probability experiment is 0.3. Yes or no?
Yes.
30 by 100 is 0.3. Okay. And this is also 0.3. Yes or no?
Yes.
Both are tallying, no? You say I am rolling 100 times. How many times I am getting the desired event? Then this divided by total events is a probability. Clear? The desired event is either 5 or 6. Right?
Okay.
I am doing the experiment. I am getting 30 out of 100 times the desired
Okay.
event. Therefore, experimental probability is 30 by 100. Understood?
Yes.
This is called experimental probability of getting 5 or 6. Now I know that there are total possibility of events is only 6 possibility, 6 items, 6 possibilities. Either I
Okay.
get 1 or 2 or 3 or 4 or 5 or 6. So getting 5 is one event, getting 6 is one event. So 2 events are possible out of total of 6 events. Therefore, theoretical probability is 2 by 6. Yes or no?
Yes.
Is this clear?
Yes.
Then 2 by 6 is 1 by 3. So theoretical probability and experimental probability I can compare. Yes or no?
Yes.
Theoretical probability is 0.3. Experimental probability also 0.3. Okay.
Yes.
Slight difference because I have tossed it 100 times, large number. That is called large number, law of large number. Okay.
Yes.
What I will do is a representation of total possible events and probability to each possible event is called probability model. Right? It is used to find the probability of an event. A probability model is used to compare different probable outcomes. All
Yes.
these three lines, have you understood?
Yes.
Compare theoretical probability with observed frequencies. Observed frequency divided by total number of items is observed probability. So theoretical probability with experimental probability.
Yes.
Discuss the discrepancies and explain law of large numbers. If there is a difference, you should tell me why is it so. Right? Okay.
Okay.
Experimental results tend to get closer to theoretical probabilities over a large number of trials. Trial means each time I toss a coin, no? Each
Mhm.
experiment is called a trial. Understood?
Yes.
Right? Actually, a small difference I'll tell you. I suppose I toss one time. That is called one trial. I toss another time. That is called another trial. Likewise, I do it for 10 times. So how many trials I have done? 10 trials today.
Okay.
Tomorrow again I am tossing it. How many times? 10 times. Each day I am doing one experiment. One experiment means how many trials? 10 trials. Understood?
Yes.
Tomorrow also I am doing an experiment means I am running it 10 trials. Now you
Okay.
know the difference between experiment and trial. Yes or no?
Yes.
Conducting is one trial. So how many times you conduct in an experiment? Maybe more than one.
Okay.
Organize a list. Tossing of a two coin I will write. And table also I will write for tossing of two coins. And tree diagram also I will write. Are you able to see this?
Yes.
I will give the example for all the three and I will close with that. Okay.
Okay.
Now here, when two coins are tossed, you will get either head or tail or head or tail. See?
Okay.
Understood? Have you seen this?
Yes.
This is called, the entire thing is called the list. This entire thing is called organized list. Understood?
Yes.
Now you can say that the probability of this is 1 by 4. The probability of this is 1 by 4. The probability of these two is 1 by 2. 2 by 4, which is equal to 1 by 2. Right?
Okay. Yes.
This is how you do it from the list of outcomes. Now I will tell you tables. This is what is called set. I showed you, I told you in the beginning. You know what is set? Yes or no?
Yes.
All the items include add HH, HT, TH, TT. Understood?
Yes.
Paired coordinates. Are you able to link that? Yes or no?
Yes.
Now, domain and range put together. Probability table. See here, first time I get head. Second time I get head. First time I head, second time tail. First time tail, second time head. First time tail, second time tail also. See, the total outcome is, and probability of this is 1 by 4, 1 by 4, 1 by 4, 1 by 4. These two are same. So 1 by 4 plus 1 by 4 is 2 by 4, which is 1 by 2. Understood?
Yes.
The same tossing of two coin, I have put it in the form of a probability table. Right? Now, tree diagram. See here. Now, I'm going to put it in a tree diagram. I'll tell you. See, I'm starting. I'm tossing. So, probability of getting a head is 1 by 2. Probability of getting a tail is 1 by 2. Clear?
Yes.
Now, again, I'm drawing another head, another tossing. So, I'm tossing after head or I'm tossing after tail. Therefore, I'll put here probability of getting a head, probability of getting a tail. Probability of getting a head, probability of getting a tail. Clear?
Yes.
This is toss 1. This is toss 2. Right? Toss 2 after head or toss 2 after tail. So, what is the probability of this? 1 by 2 into 1 by 2. What is the probability of this? 1 by 2 into 1 by 2, 1 by 4. What is the probability of this? 1 by 2 into 1 by 2, 1 by 4. What is the probability of two tails? Probability of t here 1 by 2 into 1 by 2 is 1 by 4. So 1 by 4, 1 by 4, this is 1 by 2. Understood?
Yes.
Clear?
Yes.
Therefore, there are three ways of showing probability model and calculating the probability of the desired event. Clear?
Yes.
Shall we stop with this? I'll stop with this. We'll
Okay.
continue in the next.